everyone, we're going to find the area of the region bounded by the curve y equals x cubed minus 3x squared plus 5 and the tangent line at the local minimum value of the curve. So since we're going to have to find the tangent line, let's do that first. Let's find our local extreme values. So for y prime, that's going to give us 3x squared minus 6x, and if you factor, you get 3x times x minus 2. You set this to 0. We have local extreme values at x equals 0 for this piece and x equals 2 for this piece. Now at x equals 0, we get y equals 5. And just plug that in. That's your y-intercept. And at x equals 2, that's going to give you 8 minus 12 plus 5. That equals 1. So let's do a little sketch of the graph. I'm going to go down here. All right, since it's a cubic function, it starts down in here in quadrant 3. It's going to end up here somewhere with the end behavior. Our y-intercept is 0, 5. And then we have another extreme value at 2, 1. So I'll put 2, 1 here. So again, it's not perfect, but it's going to look something like this. All right. So your minimum value here occurs right at here. This is 2, and we have a local minimum value at 1. So this line's going to be y equals 1. So the part that's bounded is this area right in here. All right. Now let's see what we can do for the equation. This is the equation of the tangent line. And now we can write our boundaries. So basically, looking at this, look at x cubed minus 3x squared plus 5, and that is going to equal your y, which is 1. So that gives you x cubed minus 3x squared plus 4 equals 0. That's going to give you x plus 1 times x squared minus 4x plus 4 equals 0. Now, factoring this, you're going to get x plus 1 times x minus 2 squared. It's basically the same thing. So basically, we have x equals negative 1, and then x equals 2. So what we're looking for is x is negative 1 right about here. That happens right about here. So that's that point. That's the main thing we were looking for. So we're going to go from negative 1 to, let's put the 2 on top. We're going to go from negative 1 to 2. And the only other thing we need to do is which one goes first. Since we're doing this with respect to x, we go from top to bottom. So the curve that is that's bounding the shaded region from the top is this curve. And then the curve or the line that's bounding it from the bottom is y equals 1. So I'm going to do that on the next slide. We're going to subtract those two. Always go top to bottom. So we got our boundaries. That was from the lower limit's negative 1. Upper limit is 2. Then you're going to write x cubed minus 3x squared plus 5. Okay, so that was the upper part of the curve that bounded the shaded region, and the lower was 1. Remember, y equals 1. But since it was at the bottom, you subtract. All right, and again, this can simplify to negative 1 to 2 of x cubed minus 3x squared plus 4 dx. All right, so let's integrate this. This is going to equal 1 divided by 4, x to the power 4 minus x cubed plus 4x. And evaluate this from negative 1 to 2. This is going to give me, let's see, for the 2 we're going to get 1/4 times 16 minus 8 plus 8. And for the negative 1, then you subtract. And for negative 1, you get 1/4 plus 1 minus 4. All right, so this piece is going to be, let's see, minus 8 plus 8 is going to go away. So this is going to be 4. And then you have, so this is 4, and this is going to be negative 3. So basically you have two negatives here, so 4 plus 3 minus 1/4. So that's going to give you 7 minus 1/4. And that simplifies to 27 divided by 4. Thank you. Have a nice day. Bye-bye.